Today we will learn transformation ratio and ratio error of potential transformation ratio of potential transformer is defined as the primary phasor by secondary phasor. So it is Vp by Vs. For transformation ratio, we have to draw this phasor diagram. This is flux and this is my I0. This is my I0. We have to find out the ratio of Vp and Vs. This Vs. So when Vs is reflected to the primary side, that is when Vs reverse, then Vs in the primary side it will be multiplied by nVs, and when secondary current reflected to the primary side, it will be Is by n. So we have to draw this diagram and accordingly we will find out it. So with the phasor diagram of potential transformer, we can see theta. Theta is the angle between the primary voltage and the secondary voltage reversed. That is the angle between Vp and Vs reversed, and this is called the phase angle of the transformer. I would like to request all the students that try to practice the phasor diagram multiple times. And delta is the phase angle of the secondary load current. That is the delta is the Vs, angle between Vs and Is. And beta is the angle between the primary current and the Vs reversed. So Ip and Vs reverse, angle between Ip and Vs reverse. Now in triangle OAB, OA is equal to OB cos theta. Now OB is equal to Vp, primary voltage. So if you see, OA is equal to, we can divide it into 5 segments. OF is equal to NVS. So OA is equal to OF plus GH, OF plus FG plus GH plus HI plus IA. The individually OF is equal to NVS and FG is equal to NIS RS cos delta, as delta is the angle between the secondary load circuit, angle between Is and Vs. So and GH is equal to NIS XS sin delta. HI is equal to IP RP cos beta. and IA is equal to IP XP sin beta. If you draw the diagram properly, then you can find out easily the value of OF, FG, GH, HI and IA. So you can take common NIS. So this is RS cos delta plus XS sin delta. So IP RP cos beta plus IP XP sin beta. So this is equation 1. Now we have to draw one perpendicular line from the I0 and Phasor sum I0 and ISN by N, that is IP point. This is C. So phase angle theta is very small, and therefore both VP and VS reverse can be taken perpendicular to phi. So VP cos theta is equal to, theta is very small, is VP. So OA is equal to VP. Now we will draw a perpendicular line from C. So this is D point. So angle OCD is equal to beta. It's approximate values, very close. So angle OCD is equal to beta, and angle ECD is equal to delta approx. So from this triangle OCD, what I can write, IP cos beta is equal to IE plus IS by N cos delta. So IP cos beta, this angle, this is beta, so this line, vertical line, so this is equal to IE I0, it has two components, one is IE, another is IN. So IE plus IS by N cos delta, and IP sin beta is equal to IM plus IS by N sin delta. As theta is very small, usually less than 1 degree, so cos theta is only 1. So OA is equal to cos theta, and this is equal to NBS from equation 1. What we can write? NBS plus NIS IP RP cos beta, IP XP sin beta is there. So NIS RS cos delta plus XS sin delta plus IE plus IS by N cos delta plus IM plus IS by N cos delta into XP. Previous one, this is into RP. So remember that, you please practice it. So VP is equal to NVS plus IS cos delta NRS plus RP by N plus IS sin delta into N into XS plus XP by N plus IERP plus IMXP. So this is equation 2. So now what I am doing, IS by N. So it will be cos delta into N square RS plus RP. And IS by N sin delta N square XS plus XP plus IERP plus IMXP. Now what I can write, N square RS plus RP is equal to equivalent resistance of the transformer referred to the primary side. So it will be NVS plus IS by N cos delta RP, equivalent resistance of the transformer referred to the primary side, plus IS by N sin delta XP, equivalent reactance of the transformer referred to the primary side, plus IERP plus IMXP. So this is equal to NVS plus IS by N RP cos delta plus XP sin delta. So plus IERP plus IMXP. So this is equation 3. So here we have to write XP is equal to equivalent reactance of the transformer referred to the primary side is equal to N square XS plus XP, and RP is equal to equivalent resistance of the transformer referred to the primary side. The actual transformation ratio no. Next is we will derive the actual transformation ratio is R is equal to Vp by Vs. Now the Vp is equal to this equation. Equation 3 represents Vp. So if I divide the equation 3 by Vs, then I can get the transformation ratio. So transformation ratio is equal to Vp by Vs. So I am dividing equation 3 by Vs. So we will get from this N plus Is by N Rp cos delta and plus Xp sin delta IERP plus IMXP divided by Vs. So this is one expression for transformation ratio. So again from equation 2 I can have another expression. So here it is NRS plus RP by N. So if I take common NIS cos delta, then inside the bracket it will be RS, then RP by N square. Similarly here it is, I am taking common NIS sin delta, so it will be XS plus XP by N square. Now this RS by RP by N square is equal to the equivalent resistance of the transformer referred to the secondary side. And similarly, this will be XS, the equivalent reactance of the transformer in the secondary side. So RS is equal to RS small rs plus RP by N square. Similarly, XS is equal to XS by, this is capital X, this is small xs, XS by XP by N square. So actual transformation ratio is equal to BP by BS. This is equal to this one, and the difference between the actual transformation ratio to the turn ratio is equal to R minus N by this. R minus N is equal to ISN by N, RP cos delta plus XP sin delta plus IERP plus IMXP by BS. So this is equation 6. Now the voltage, the ratio error, that is the ratio error of potential transformer, that is the voltage error, right? So actual ratio error varies from the operating condition, and error in the secondary voltage may be defined as percentage ratio error is equal to Kn minus R by R into 100. Thank you very much for watching. You need practice to answer these questions.